Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everybody. Alright, in this video I'll be covering on software evolution. Right, so these are the topic covered: evolution processes, and then legacy system, old system, and how do we do software maintenance after that. Okay, you keep on hearing about software change for quite some time already, right? So it can happen because new requirement is being added, change in the business environment, some error that occurs when the system are being used and must be repaired, new platform, new equipment, and then due to better needs for higher performance and reliability, some parts of the code need to be changed. So due to that reason, changes need to be addressed. So when we are talking about evolution, we need to be thinking about that for an organization to buy a software is actually a huge investment already. So you need to be able to maintain it in case in the future there are some changes, updates that you need to do on the in the software on the software. So that is part of what happened in the evolution, right? Evolution can be think about can be visualized similar to what spiral model is representing. Okay, it start with nothing, and then gathering requirement and so on, and then the coding, and then the testing are being done, right? And then there is a first release, and then the following round and round. So that is evolution, right? So adding to the software, all right. And then in when we are talking about evolution, we are not only talking about when the system being developed, okay, and then additional requirement are being added after it's been used, and then you need to maintain it, and then at certain point of time, maybe the software need to be retired, meaning that it is no longer being used. Okay, when we are talking about servicing, we are talking about we are dealing with maintaining the software, maybe like fixing the bugs, changes. It's not that much. Okay, no new functionality is being added. So when we are talking about evolution, maybe we still keep on adding the requirements. Right? Phase out. When you say phase out, basically you are only maintaining it. Okay, the system are very stable already. Right, let's look at the processes. When we are talking about evolution of the software, so what processes to be applied is actually depend on the type of software to be maintained, what process model or development processes that have been used, and also the skills and experience of the people that will be involved. Right, the key driver for software evolution is proposal for change. There is a request made by the user to change it. All right, so we started off with for example, the system had been running, and then there is change of proposal. So because there are some requests for change, the system, after it is being approved, there is some changes in the software has been added and modified, and then it become maybe a new system or new version of the system. And then after quite some time, the user are comfortable with it, and then they start asking for change, and it goes around and around. So basically these are overall a big picture of what happened during evolution. Okay, so a more detailed process what happened in handling software evolution is like what you have seen here, and it looks slightly similar with what you have learned in configuration management. Configuration management and evolution is actually running in parallel, whereby the configuration management is handling the storing, the documentation part of the changes, whereby evolution is the actual process done on changing the software. Okay, so whenever there's a change request, they have to analyze it whether to proceed or not, looking at the costs, benefits, and then when it is agreed to proceed, so they will start to do the planning part. and when it's ready, they start to do the changes, the change implementation, the coding, the development, the testing part on the new added codes. And when it's ready, we release it, and then after quite some time there will be another change of request. Okay, so looking at the change implementation phase in a greater detail. So before any proposal changes could be done, remember this is evolution. So it is done after the software are already ready. Okay, so the programmer that is going to do the changes need to do some analysis first on the current system, read the specification manual, look at the test data and so on, and after that updating the requirement, and then modify the system. Okay. Sometimes there is a request for change that must be done urgently. Okay, situation that might happen is that maybe a serious system fault happened, that you need urgent changes to make the system running, or maybe the organization invests on a new system environment, or upgrade on OS, but it caused the system to uh, cause certain error or not running as usual. Or sometimes the business change because the organization changed to a new business domain, maybe from hotel to grab food, for example, for food online delivery system. So due to that reason, the system need to be changed urgently. Okay, so if this happen, the code are not being analyzed as at all, or sometimes done in a very minimal uh, is spent at a very minimal time. Okay, because this is urgently need to be done, so the focus is more on delivering the new changes. All right. In this slide is showing how evolution in the relation to agile methods. So in agile method, evolution is actually cannot be separated clearly, because evolution is actually part of agile methods, where it is supporting continuation of process development, whereby automated regression testing are always done, and also if there is any changes to the user story, any additional to the requirement is actually considered as additional user story in every sprint, every cycle, right? It's just that I've mentioned just now, when we are dealing with evolution process, we need to think about also to consider the process development that are being used. For example, what happened if a development team, when they are developing the software, they are using agile approach, whereby the team that handle the evolution part is actually using something else, which is plan-based approach. So you could imagine the different expectation that this team would have. Okay, so the evolution team that is using plan-based approach, for example, waterfall or spiral model, for example, they are into detailed documentation, right? But for the agile team, from the development team, is not producing that documentation. So imagine the trouble that is caused. The same goes when it is the other way around. Okay, meaning that the developed team is using plan-based, whereby the evolution team is using agile method. So the different method actually cause some confusion and lack of information among them. Okay. Okay, let's look at a related topic related to evolution, which is legacy system. Legacy system can be considered in easy way to understand is referring to old system, where it is using languages and technology is no longer used in the new system development nowadays. It's there, it's just that there is no additional extension, or it might not be used in the newer system. All right, So not only that, we are talking about hardware and software, we are also talking about um, software libraries, supported software or business processes that is no longer used in the new environment, the new development environment. Okay, so these are actually talking about, I mentioned just now, we are not only dealing with hardware, software, also with data, because legacy system is all has been developed before long back. So maybe they do store the data that you use for test data and so on. Even sometimes the business processes are being coded in the mainframe are not no longer used by the organization, for example. So sometimes the organization have to decide not to change the business process, because if they change it, they cannot the legacy system cannot be uh, changed to adapt to their new processes. Okay, even the business rules sometimes cannot be changed because it is actually hard coded. All right, um, so that's some of the issues dealt with organization that is using legacy system. In legacy system can be represented using uh, architectural layer architecture. Okay, so this is the architecture that is mostly supported by legacy system. Right. So when you have legacy system, there are several decisions. When you are managing legacy system, there are several decisions that you can make. Either you can replace it, okay, or you modify it, you maintain it, or you scrap it, you remove it totally. Okay. In case that the organization decided to replace it, so again, this is very risky and expensive, because the organization has been using the system for quite some time, right? So the user are used, the staff are very used to it, right? So but this year the riskiness and the cost that might incur if you replace it is that maybe the legacy system that are being used is very tightly integrated with the system, because it has been there for quite some time. So other applications are built on top of it, right? Um, and then some of the business rules are not documented. Okay, sometimes it is hard coded in the system, and if you and of course the system specification documentation are not complete. Okay, because it's an old system. Any changes happen on it, maybe the specification of that exists is not the updated one, right? So if you want to develop a new system, of course, it will take you some time, right? You cannot use it straight away. So in case that you want to change, you still want to use the legacy system, but you want to change some parts of it, right? Some of the challenges and some of the reason why it is expensive to do is because newer generation of programmer, most of them are not well trained for slightly older programming languages, right? Which is where um, the legacy system uh, was used or being developed from. Okay, so of course, because you want to change, you need to to read the system documentation. So most probably it is inadequate. Adequate. If you want to go to refer to the test data to run it, okay, maybe it's not there, or maybe there is some error, right? So these are some of the issues that make that you need to consider if you plan to change the legacy system. That's why you need to, I've mentioned just now, if you are using a legacy system, you need to manage it. You can either replace it, you transform, change it, you continue using it without changes, or you scrap it totally. All right, the decision of which action or which decision to be selected depends on the evaluation done on the system quality and also business value. Right. So this is the graphical way on on analyzing on the business value and system quality. Okay, which one is having this is not a one-man job. Okay, it is done by a team of stakeholders. Okay, based on the analysis done on the business and also system quality and the business value, whether it's low or high, it will give you some decision. For example, if it's from the analysis, if you decided that the legacy system is having low quality but very and also low business value, it's better to scrap it, right? If it's a high quality and high business value, maintain it. Okay, the one that is low or high on the aspect will uh, you can either scrap it, maintain it, or do re-engineering. Okay, I mentioned just now it's not a one-man job, it's a collective decision done from getting the feedback from a group of business user, okay, and also the organization staff. Okay, when we are looking at the business value aspect, we should be looking at does the system use occasionally? Does it support the business processes? Okay, um, does it depend on other systems? Okay, we want to see the integration that might exist, and we want to see how far the system depend on the output of the system. We should bear in mind that in an organization there are many systems. So the one that we are talking about is a legacy system. Maybe there is a legacy system that the company is maintaining, but they are not being used anymore. So you need to do this analysis to decide whether to stop using it or to proceed. Right. So looking at the quality assessment just now, right? There are two parts: business process and quality assessment. This is the second part, which is the quality assessment. We'll be looking at the business process assessment. Okay, we are looking at environment and also application. Okay, let's have a look. From business process assessment, again, this is a collective discussion that you need to do. You have to, among the questions that you can ask is the legacy system is following certain process model. Okay, um, uh, is the legacy system is implementing business processes that is supported or integrated with other business processes used by other systems, right? How effective the legacy system is in supporting the business processes. Okay, so looking at the environment aspect, you can look at the how the age of the software or hardware that is used in the legacy system. Is it sometimes there is no problem with it. It's just that the organization need to look ahead of time. Okay, maybe there is no problem with the system, but in the future, is it expensive? You need to look how from the aspect of cost effective. Is it cost effective to maintain the legacy system? All right. So maybe we need to look at the supplier stability, the company that is supplying the hardware which is no longer used by might might not be used by many customers anymore. So maybe in the future, maybe that supplier decided to stop supplying the hardware, for example. So what will be the effect? Okay, we have look at the failure rate produced by the legacy system. Is it high or not? So does it produce the performance that you want? All right. So you should be also looking at the support requirement. Is there any local company that is there to help you in case there is any problem in the future with the legacy system? right? In terms of the maintenance cost, in terms of the software licensing that you have to pay because you don't, this is an old system, so you don't have much option. Maybe you need to maintain it, so you need to see whether the annual licensing cost is it very high in the future compared to if you use a new system that are being developed by many companies where maybe the price will be more competitive. You want to also see in terms of the interoperability, because you not only that you are running on a legacy system, maybe you'll be using new other software are being there in the organization to work together with the legacy system. Is there any interoperability issues? Right. So just now we look at environment assessment. So the other assessment that can be performed is on the application itself. Okay, on the software legacy itself, is it easy to understand? Is there any documentation and data available in terms of performance? Is it meeting your expectation? And again, we are looking at application. We are looking at the programming languages being used. Do you have the right people to help you to maintain the system? Is this application having configuration management that is maintaining the documentation, the previous version, and so on? In case in the future you want to extend it, test data for regression testing is there available, so that when you keep on adding new functionality, you need to do regression testing. So you want to see the previous test data, and also on the personnel skills, whether they are able to produce the right skills for performing programming languages and so on. And of course, when you want to do this assessment, you need to have some data to support, right? So you need to collect some of this data ready so that you can see, you can make decision from the numbers, among the possible or suitable data that you can look for from this legacy system is change request made. So if you have configuration management system, then you can have this data, and then you want to see different user interfaces used by the system. You want to see whether there are some inconsistency between them, and also you want to see how far this legacy system use the data. Okay, how much files they use. Does the system slow down if you keep on adding larger data? You want to see some inconsistency and error with the data and so on.